You've definitely heard the headlines, right? AI is coming for every developer's job. But what if that's the wrong way to look at it? What if this isn't some sudden AI revolution, but actually a software evolution that's been quietly happening for the last 20 years? Today, we're going to break down a really insightful argument from Phil Calzado that might just change how you see the future of code. You see this stuff everywhere. It feels like you can't open LinkedIn without some new AI demo that's supposedly the end of software engineers as we know it. It's a very dramatic story, but it might be missing the real story completely. So, the easy take is that AI is just getting so incredibly powerful that it can now write code. But the real story, the one we're exploring today, is that the software world has been reshaping itself for 2 whole decades, basically creating the perfect conditions for AI to step right in. It's not so much about AI's power, it's about its perfect timing. To really get why AI's timing is so perfect, we have to go back. Let's take a quick trip down memory lane and trace the journey from software in a box to the cloud and see how that whole process really set the stage for everything that's happening today. Okay, remember the 90s? Software came in a literal shrink-wrapped box. Developers used tools like Visual Basic to build apps that were pretty much just nice-looking fronts for a database on your computer. Then, of course, the internet changed everything. Software moved into the browser, becoming software as a service. And the game changed again with frameworks like Ruby on Rails, which put a massive, massive emphasis on developer productivity. This whole shift created two totally different kinds of developers. The 90s developer was kind of an assembler, you know? They focused on the business logic and piecing together pre-made components. But the 2000s web developer, whoa, they had to become a deep engineer, building pretty much everything from the ground up. Authentication, scaling, deployment, it was a much more complex, much heavier job. And all that complexity, all that heavy lifting led directly to the next crucial shift in our story, what we'll call the Great Delegation. Developers pretty quickly realized they couldn't and probably shouldn't build everything themselves. Build versus delegate became the defining choice. Frameworks like Ruby on Rails totally changed the culture, making it not just acceptable, but actually smart to rely on other services. Productivity became king, and the best developers weren't the ones who built everything from scratch, but the ones who were experts at delegating. And the result of that? An absolute explosion of specialized services, the API economy. I mean, why would you build your own payment system when you can just plug in Stripe? Why handle user logins yourself when Auth0 can do it for you? All of a sudden, developers could offload these huge, complex parts of their applications with just a simple API call. Which brings us to a really fascinating full-circle moment in the history of software. It turns out we've kind of been here before. Does that sound familiar? It should, because today, building a typical business app isn't about deep, complex engineering. It's about orchestrating these incredibly powerful pre-built components, Stripe, Algolia, Vercel, and then just writing the glue code that holds them together and contains your specific business logic. We're pretty much back to the 1990s model, just with way, way more powerful Lego bricks. So a modern developer's job often looks a lot like this. It's become less about engineering and more about translation. You understand a business need, you pick the right tools off the shelf, and then you write the code to connect them all. And this is the million-dollar question, isn't it? For years, companies have tried to cut out the developer with no-code or low-code platforms. If the job is just gluing things together, why haven't those tools succeeded? Well, there are two big reasons. First, you had to learn a whole new, often weird, proprietary system that wasn't useful anywhere else. But more importantly, they always sacrificed power for simplicity. You could do the basic stuff, sure, but the second you needed something custom or complex, you just hit a wall. They weren't flexible enough. And this is where AI enters the picture. Not as some master engineer, but as the final missing piece of the puzzle that we've been building for the last 20 years. See, AI is the ultimate translator. It has the potential to understand business needs in plain English and then turn them into that glue code needed to connect all of our powerful pre-built components. It solves that old no-code dilemma by offering incredible power with a near-zero learning curve. And this right here is the key insight. The ecosystem for this to happen was already in place. The powerful APIs, the cheap infrastructure, the culture of delegation. All the building blocks were already there. They were just waiting for an interface that was powerful and intuitive enough to control them. And that interface is AI. This wasn't an overnight revolution. Not at all. This was the end result of a slow, 2-decade-long trend of abstracting away complexity in software development. So the crucial point is this. AI's disruption comes less from its ability to be an engineer and more from its ability to act as an interface to an ecosystem that no longer requires deep engineering for a lot of common tasks. It's the right tool at exactly the right time. The source puts it perfectly with this analogy. Think about what Heroku did for cloud computing. It made it accessible to millions of developers by simplifying it. Well, AI has the potential to do the exact same thing for application development itself, making the power to build software accessible to a much, much wider audience. And that leaves us with a really fascinating question for the future. As AI takes over more and more of the glue code and the orchestration of today's apps, what new, harder, more interesting problems will human engineers finally get to solve? What does the next level of innovation even look like?